Okay, I hope I am audible to all students who are attending this lecture for the JNU MA Economics entrance. In this particular lecture, I intend to start with the discussion for the JNU School of Social Sciences 2020 entrance for MA Economics. Okay, and in this lecture, we are starting with the discussion from question number 1. Okay, so let's look at question number 1. What will be the slope dk by dl for the given isoquant 4k to the power 1 by 4 L to the power 3 by 4 equal to 2000? Okay, so it's a very easy question. Let's quickly come to the whiteboard and solve this question. Okay, so we continue with our discussion of the JNU entrances for MA Economics, and in this lecture we are starting with the discussion for JNU SSS 2020 MA Economics entrance discussion. Okay, so let's look at the first question. Quickly writing first of all what is given. So we are given the equation of the isoquant. We are given the equation of the isoquant, which is as follows: 4k to the power 1 by 4 L to the power 3 by 4 is equal to 2000. This is the equation of the isoquant given to us, and all students should be able to recall. We have done the concept of isoquant in our introductory as well as intermediate microeconomics course. An isoquant gives us combinations of capital and labor which produce the same level of output. So I'm just writing it. Recall, an isoquant. An isoquant shows combinations of capital and labor which produce the same level of output. Which produce the same level of output. And all students can recall that the slope of the isoquant is what? The slope of the isoquant, which is dk by dl, is nothing but minus marginal productivity of labor upon marginal productivity of capital. How do we find the marginal productivity of labor? You differentiate the isoquant with respect to, suppose in general my production is given by Q. So when I differentiate the production with respect to partially with respect to labor, I get MPL. When I differentiate the production function partially with respect to capital, I get MPK. So guys, from this you can see that Q is equal to 4k to the power 1 by 4 L to the power 3 by 4. This is my production function, and for the given isoquant, my output level is constant Q bar, which is equal to 2000. But in general, this is my isoquant equation of the production function. This is my equation of the production function. This is the isoquant for a fixed level of output 2000. But this is my production function. Q is equal to 4k to the power 1 by 4 L to the power 3 by 4. So this is my production function. Okay, so quickly we can find out del Q by del L. We know how to partially differentiate Q with respect to L. So 4 into 3 by 4 k to the power 1 by 4 L to the power 3 by 4 minus 1. This comes out as 3 times k to the power 1 by 4 L to the power minus 1 by 4. And then del Q by del K, if I partially differentiate the production function with respect to K, what do I get? 4 times 1 by 4 k to the power 1 by 4 minus 1 L to the power 3 by 4. 4 and 4 cancel. We get k to the power minus 3 by 4 L to the power 3 by 4. So guys, the slope of the isoquant will be, the slope of the isoquant is going to be dk by dl, which is going to be minus del Q by del L, which is this term, divided by del Q by del K, which is this term. So this is going to be minus. If I calculate this, guys, you can use the powers. So I take K on the top. So 1 by 4 plus 3 by 4 makes it K only. And I take L to the power minus 1 by 4 in the denominator. So L to the power 3 by 4 plus 1 by 4 is again L. So my answer is minus 3k by L. So the final answer for question 1 is minus 3k by L. That's the slope of the isoquant. You can clearly see that the isoquant is downward sloping. Okay, because to produce the same level of output, if a firm employs more labor, it has to give up some amount of capital. Okay, so I can come back to the question paper and we can mark the correct answer. Okay, so coming back to the question paper, the correct answer is minus 3k by L. This is the correct answer for this question. Okay, let's look at question number 2. For the economy, we are given that the consumption function is 400 plus 0.8 YD, where YD stands for disposable income, which is equal to your income minus the lump sum tax. The lump sum tax is given to us by the function, the tax function. This is not the lump sum tax actually. This is the tax function given to us, which is 300 plus 0.2 Y. The question is asking us to find out the marginal propensity to consume. Marginal propensity to consume is nothing but the slope of the consumption function. And marginal propensity to consume indicates that when your income goes up by $1, by how much will your consumption go up? So we have done this in our lectures on consumption function within our introductory macroeconomics course. Okay, we have also done this in our Keynesian economy lectures. So coming back to the whiteboard, let's quickly solve for this question. Okay, let's look at question number 2. So quickly writing, first of all, what is given to us? We are given that the consumption function is 400 plus 0.8 times YD, and YD itself is equal to capital Y minus T, and my tax function is 300 my plus 0.2 Y. So I can write that YD denotes my disposable income. Okay, what do we need to find out? Okay, and you know that C denotes consumption. I'm writing for perfect clarity so that students are not getting confused. C denotes consumption, Y denotes your income, and T denotes the tax. You should be familiar with all the symbols. Okay, objective is to find out the marginal propensity to consume, which is nothing but derivative of the consumption function with respect to income. So first of all, let me look at the consumption function, which is 400 plus 0.8 YD. Now guys, let me put in the value of YD. What is YD? YD is equal to Y minus T. And now I'm putting the value of T. What is T? T is nothing but 300 plus 0.2 Y. 300 plus 0.2 Y. So my consumption is equal to this. If I further solve, 400 plus 0.8 times Y minus 300 minus 0.2 Y. So therefore, my consumption is 400 plus 0.8 times Y minus 0.2 Y is 0.8 Y minus 300. And if I solve this further, this is 400 plus 0.8 into 0.8 is 0.64 Y minus 0.8 into 300 is 240. So my C is equal to 400 minus 240, which is 160 plus 0.64 Y. This is my Keynesian consumption function. And from this, you can see that your marginal propensity to consume is nothing but the derivative of the consumption function with respect to Y. If I differentiate the consumption function with respect to Y, what do I get? 0.64, which is nothing but my marginal propensity to consume, which indicates that if my income goes up by $1, my consumption goes up by $0.64 or 64 cents. Okay, so this is the correct answer. Coming back to the question paper, we can mark option B is the correct answer. Okay, so hoping students have understood question number 2. Let's quickly look at question number 3, which is given to us. What will be the equilibrium income when the lump sum tax is added to the model? Consumption is, okay guys, there is a small piece of information missing here, so all students can write this. our autonomous consumption is given to us as 100. Okay, I'm writing everything. Autonomous consumption is 100 given to us. B, which is my slope of the consumption function, is 0.5. My autonomous investment is 40 and my lump sum tax is 50. So for question 3, I repeat that we were not given in this particular question. I'm modifying it slightly. There's a misprint here, so please correct it. Autonomous consumption is given to us as 100. The slope of the consumption function is 0.5. Autonomous investment is 40. Rest everything is the same. Tax is 50. Okay, so let me come to the whiteboard and let's solve for this question. Okay, so erasing this part off, let's look at question number 3. So we are given that the consumption function is given to us. So I can write that C bar is 100 given to us. The slope of the consumption function is 0.5. Autonomous investment is 40 and the tax is 50. Okay, what do I need to find out? We need to find out the equilibrium level of income. We need to find out the equilibrium level of income for the economy. That's a very easy question. So let's quickly do that. So we know that Y is equal to C plus I. Very simple. What is C? C is equal to C bar plus your B times Y. But now, guys, we have YD. So my disposable income is Y minus T. Remember, YD is equal to Y minus T, where YD denotes your disposable income. YD denotes your disposable income. Since we have a tax here, so my disposable income is Y minus T. Okay, plus I is equal to I0. So I can write that therefore Y is equal to how much is C bar? Autonomous consumption is 100 plus B is how much? 0.5 times Y minus capital T is 50 and I0 is 40. So this implies Y is equal to 100. Now I can solve this further. Plus 0.5 Y minus 25 plus 40, which implies Y is equal to 100 plus 40 is 140. 140 minus 25 is 115 plus 0.5 Y, which implies Y minus 0.5 Y is equal to 115, which implies 0.5 Y is equal to 115. Therefore, my equilibrium level of income Y star will be 115 upon 0.5, which is 115 by 5 into 10. So my Y star comes out as 115 into 2 is how much, guys? It's 230. So this is the final answer for this question. The equilibrium level of income for the economy given the following data is 230. So I can come back to the question paper and we can mark the correct answer is 230. Okay, and then let me look at the last question for this lecture, after which we stop in this particular lecture. Let's look at question number 4. Mrs. Sulekha wants to buy 2 goods, samosa and jalebi, when she is having the money income of 200 rupees. The price of samosa is 10 rupees each and the price of jalebi is rupees 4 each. Okay, and the question is asking us what proportion of the income should be allocated on samosa and jalebi to maximize the utility when the utility function is given to us as square root of x1 and x2, where x1 and x2 denote samosa and jalebi respectively. Very easy question of simple utility maximization. It's a Cobb-Douglas function. You can see that. Okay, so let me come to the whiteboard and let's quickly solve this question. So we look at question number 4. Quickly writing, first of all, what is given to us. We are given that there are 2 goods, x1 which denotes samosa and x2 which denotes jalebi. Okay, and we are given that the income of the consumer is 200 rupees. We are given that price of good x1 is 10 rupees, price of good x2 is 4 rupees, and the utility function. So first of all, what is the budget line? The budget line for this consumer is x1 times the price of good x1 plus x2 times the price of good x2. This denotes the total expenditure by the consumer on x1 and x2 equals the total income of the consumer. So I can write, if I substitute for the prices, I get 10x1 plus 4x2 equal to 200. Now my objective is to maximize utility, which is x1 to the power half, x2 to the power half, because square root of x1, x2 I can write as x1 to the power half, x2 to the power half, subject to the budget line. 10x1 plus 4x2 equal to 200. Okay, so let's quickly solve for this. Where will the equilibrium happen? So I can write in consumer equilibrium. Since it's a Cobb-Douglas function, the equilibrium happens at the tangency of the budget line and the indifference curve. That means the absolute value of the slope of the indifference curve, which is MRS, should exactly be equal to the slope of the budget line, which is the ratio of the prices, Px1 by Px2. So if I calculate the MRS, how do I do that? In absolute terms, it's nothing but del U by del x1 upon del U by del x2. Px1 is 10, Px2 is 4. Okay, so how much is del U by del x1? I partially differentiate the utility function with respect to x1. I get half x1 to the power half minus 1 x2 to the power half upon del U by del x2 will be half x1 to the power half x2 to the power half minus 1 equals 10 by 4, which implies half cancels. I get x1 to the power minus half x2 to the power half upon x1 to the power half x2 to the power minus half equal to 10 by 4 is how much? 5 by 2. So if I erase the initial part, let us see what do we get. Okay, so I can write that this, I can write it as, so guys, x2 to the power half and x2 to the power minus half, I can write it as x2 to the power half plus half, which is 1, upon, I take this in the denominator, x1 to the power half plus half, which is x1. So this is equal to 5 by 2, which implies that what does x2 come out as? So x2 is 5 x1 by 2. Now I put this in the budget line. This is my budget line. I can mark this as equation star. So putting this in equation star. Putting this in equation star, what do we get? So erasing this part off. So my budget constraint is 10x1 plus 4 times x2. I can write as 5x1 by 2 equals 200, which implies 10x1 plus, this is 10x1 equal to 200, which implies 20x1 is equal to 200, which implies x1 is 10. Or I can say my, since it's an equilibrium value, x1 star is equal to 10. Now I can put it here and get x2 star. So my x2 star will be 5 by 2 x1 star, which is 5 by 2 times 10, which is 25. So guys, I get x1 star as 10 and x2 star as 25. Now what is the proportion of the expenditure on x1? So proportion of the expenditure on x1, which is samosa, is equal to p1 into x1 star divided by income. How much is p1 into x1 star? Px1 is nothing but 10. x1 star has come out as 10 upon the income is 200. So what is the percentage? If I multiply the proportion by 100, I get the percentage. So therefore, percentage of the expenditure on x1 will be 10 into 10 upon 200 into 100, which comes out as 50%. On similar lines, we can find out the percentage of expenditure on x2, which is jalebi. So I can write that therefore percentage of the expenditure on X2, which denotes jalebi, is P2 X2 star by M, and since it's a percentage, I multiply by 100. So P2 is how much? 4. X2 star has come out as 25. Income of the consumer is 200 in 200. So again, this comes out as 50%. That means the consumer, if I interpret it, the consumer is spending 50% of its income on samosa and 50% of its income on jalebi. So I can come back to the question paper and we can mark the correct answer. 50% is on X1 and 50% is on X2. This is the correct answer for this question. So students, this is where I intend to stop in this particular lecture. The objective was to discuss the first 4 problems from the JNU 2020 entrance for MA Economics. In the next lecture, I will be starting with my discussion from question 5 onwards. So I hope all students have enjoyed this lecture. Any doubt, you can unmute your mic and ask, or call up or mail me your doubts at divineschoolofeconomics@gmail.com. This is where I stop in this lecture.